Let's go ahead and take a look at deductive reasoning. Previously, I had discussed inductive reasoning, and when I talked about that, I had said that the inductive reasoning was more or less the weaker type of reasoning that we have, and deductive is going to be the stronger one. Inductive reasoning is based on patterns. You make observations based on patterns, and then you come up with conjectures that may be true or they may be false. Most of the time, they end up being correct. They're correct, but the problem is that you never go through a process of actually proving them if you're just sticking with inductive reasoning. Well, deductive reasoning, if you bring that in, what you're going to do is use facts, you're going to use definitions, you're going to use accepted properties, things that we all know to be true. We've agreed upon that these are true, and you're going to use the laws of logic to form a logical argument. That last part's a little bit weird there. But you're going to be using things that we all know are right, facts and definitions and accepted properties, or maybe even other things that we've proven beforehand. Okay, we're going to use things that we know to be absolutely true, and we're going to build fluidly, okay, that's using the laws of logic to form a logical argument. We're going to build fluidly to prove what it is that we want to prove. In this video, we're not going to get to the process of writing proofs yet. We're still going to hold that off for a little bit later. But what we're going to do is address two very particular laws of logic that we may be using in the process of writing proofs later on. First, what we have is the law of detachment, which says if the hypothesis of a true conditional statement is true, then the conclusion is also true. So this all begins with a conditional statement that is true, something that we already have agreed upon is right. A hypothesis leads to a particular conclusion. Okay, so that exists. We then are either told something or we find something that fits the hypothesis. And if that item fits the hypothesis, then we are able to draw a conclusion respective to that item or thing that fit the hypothesis. So for example, number one, we're given a conditional statement that we agree upon, and that's this. If two segments have the same length, then they are congruent. We should agree that that is true because that's the definition of congruent segments. Segments with the same length are congruent. So we know that to be true. We then are provided something, or we find something like this that says BC equals XY. All right, now remember that that is interpreted as reading the distance from B to C is equal to the distance from X to Y. Okay, so we're told that we've got these points that are the same distance away from each other, they're equidistant. If we were to connect B to C and actually turn that into a segment, and connect X to Y, make that into a segment, we would be saying that the length of segment BC is the same length as segment XY. Okay, so that fits the hypothesis. That means that we can then make a conclusion. Okay, we can say that line segment BC is congruent to line segment XY. Okay, so we have the true conditional statement that says if the segments have the same length and they're congruent. We are told that a couple of points are equidistant from a couple other points, so therefore the segments connecting them would be equal, and we can write this statement that the line segments BC and line segment XY would be congruent. The other law of logic that we're going to look at is going to be called the law of syllogism. This one we're going to use quite a bit when we're writing proofs, except when we get to the proof writing stage, it is going to go by a different name. So just kind of a heads up on that one. You're going to notice this pop up again later, but it will be used by a different name. All right, so it says that two conditional statements can be simplified as one conditional statement if the two statements fit the diagram below. So what we begin with here is two conditional statements. They're going to be vaguely stated here. They're not like actual examples. So you've got hypothesis P, you got hypothesis Q, you've got conclusion Q, conclusion R. Okay, but what we want to do is look at the flow of things here. The first says that if hypothesis P, then conclusion Q. So you can kind of think of it as like this, that if hypothesis P exists, it's going to lead to a conclusion Q. So you can think of it as that hypothesis P will lead to having a conclusion Q. The second statement says that if you have hypothesis Q, the same thing that we see up here actually, if you have hypothesis Q, that would lead you to conclusion R. In a way, Q, whatever it is sort of like a middleman here. a stepping stone. Okay, P is going to lead us to Q. Q is going to lead us to R. So if P happens, and we know that Q is going to occur later, and Q becomes R, if P happens, then eventually we're going to get conclusion R. So we could just simplify all of that as one statement and say, if hypothesis P, then conclusion R, and not mention Q at all. Just go ahead and leave it out. All right, let's go ahead and try this in the context of a problem. We've got two conditional statements here. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. Okay, Rick takes chemistry, he's going to be working with Jesse. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. Okay, so what you want to notice here is that the conclusion part from the first statement, Jesse will be Rick's lab partner, is the same as the hypothesis in the next one. Okay, so we can actually just sort of take that out here, and we can write this. We can say, if Rick takes chemistry this year, okay, if Rick takes chemistry this year, comma, yeah, Jesse's going to be his lab partner, and then when Jesse's his lab partner, Rick will get an A in chemistry. So we'll say, if Rick takes chemistry this year, then Rick will get an A in chemistry. I mean, it's important that he's going to have Jesse as a lab partner, but the idea of the law of syllogism is that we can take a beginning hypothesis and then jump to a later conclusion.
Later, what?